Okay, so once again, welcome to part two of our weather and forecasting. Joining me today, our SME, first of all, just like to introduce David Wilson. He's an accident investigator from the ATSB. And along with us yet again, we have Michael Paech, Senior Aviation Meteorologist from the Bureau of Meteorology. What we are covering today in part two is, first of all, a bit of a recap of our alternate and VMC criteria that we talked about in part one of the series. I'll then hand over to Dave Wilson, who will talk to us about the role that weather plays in reported incidents and accidents, which includes a short case study. And finally, Michael will explain how to interpret the weather aviation forecasts available and forecast by the BOM, including reading the synoptic charts, and we'll also be using examples that I've placed in the chat. And hopefully you've got a copy of those examples too when the link for the webinar was sent out. We'll be using those examples of the TAF, the GAFs, and the grid point wind and temperature examples that were sent to you in the link in the webinar. So first of all, a bit of an overview. So correctly reading and interpreting the weather forecasts, they are fundamental to planning and of course having a safe flight. We have covered what our pilot in command responsibilities and requirements are for obtaining weather forecasts during pre-flight planning, as well as our VMC weather requirements in the first webinar. But what good are these NAIPS briefing products if we can't understand them? Certainly aviation is a language unto itself, and the decodes are found in the VFRG, the Visual Flight Rules Guide, available on the CASA website, from about page 124 onwards. Also in the AIP, in the General Section 2.2, entitled General and Meteorological Abbreviations. And don't forget, there is a really good TAF reference card on the BOM website as well. Some EFBs as well are able to translate the forecasts into plain language, but it's certainly fundamental for us as pilots that we can read the forecasts as they stand as we get them out of NAIPS. So let's have a quick look again at what our alternate requirements are for VFR flight. So if there is a TAF for the aerodrome available, an alternate is required if you're arriving during the forecast of or 30 minutes prior to or the 30 minutes after the forecast of more than, as they say there, the cloud scattered, more than scattered below our alternate minima, visibility less than the ultimate minima, or there's forecast of 30% probability of fog, mist, dust, or any other weather phenomena reducing visibility below the alternate minima. Then of course we have our wind. If it's headwind, crosswind, or even a downwind component that exceeds the maximum permitted for your aircraft, and thunderstorms or associated severe turbulence or forecast of at least 30% probability of its occurrence. Now they do say and make reference to the alternate minima. So what is the actual alternate minima? Well, for aeroplanes by day and night VFR and helicopters by day and night VFR for aerodromes other than in Class G, then the ultimate minima is cloud more than scattered below 1,500 feet, visibility 8 kilometres or less. For helicopters by day VFR, going to aerodromes that are in airspace other than, going to aerodromes that are in Class G, our cloud is more than scattered below 1,000 feet and visibility of 3 kilometres or less. Now there's buffer periods as well. So except for when in the first 3 hours of a TAF3 or when using an ICAO landing forecast, the application of a 30-minute buffer to the beginning and the end of a forecast weather conditions that require a destination alternate or carriage of holding fuel. This also applies to any inter, tempo or becoming periods. Don't forget with the becoming, if the forecast includes a change indicator of becoming, the deteriorating weather conditions that are associated with that becoming part of the forecast are taken to commence at the start of the becoming period. When a destination forecast, so a TAF or a TAF3 is not available, you must nominate an alternate aerodrome. Also, where alternates are not required, so pilots don't need an alternate when you are flying within 50 nautical miles of your departure aerodrome, And also you carry relevant holding fuel, allowing holding for 30 minutes after the end of forecast weather conditions. And you're carrying fuel to hold for the relevant period for forecast inter and tempo periods. Don't forget, if it is a bit of a complex TAF and it has multiple inter or tempo periods in that particular forecast, you must plan for the most limiting requirement. Now, contained in our Civil Aviation Safety Regs Part 91 and also in the associated manual of standards and also contained in our VFRG, looking at our en route VMC minimum. So we've had a look at our alternate criteria, but what about the in-between bit, our cruise, our en route segment? So when we're flying VFR under 10,000 feet, we require a flight visibility minima of 5,000 metres, and we need to keep vertical clearance from cloud 1,000 feet, horizontal distance of cloud of 1,500 metres. If we're flying 3,000 feet below 1,000 feet AGL, flight visibility minimum required is 5,000 metres, and we must remain clear of cloud, and that's in Class G airspace only. If we're flying in Class D airspace, so Class D, we need to be 1,000 feet above cloud, 500 feet low, 600 metres horizontal, and 5 kilometres visibility. So 500 feet below cloud, minimum visibility of 5,000 metres and 600 metres horizontal distance from cloud. For our helicopter pilots, flying VMC en route, flying at 700 feet AGL, and you're tracking over land with or without track guidance, or you're tracking over water with track guidance provided from a navigation system, then you must remain clear of cloud with a flight visibility of 800 metres. If you are flying over water without track guidance from a navigation system, then you must maintain 500 feet below cloud, minimum visibility of 5,000 metres, horizontal distance from cloud is 600 metres. And don't forget too, by day, you must fly at a speed that allows the pilot to see obstructions or other traffic in sufficient time to avoid collisions. And if you are within 10 nautical miles of an aerodrome with an instrument approach, you must fly in a way that ensures the flight maintains separation of at least 500 feet vertically from any IFR aircraft that is also within 10 nautical miles of the aerodrome. Now, bearing all of what I've spoken about in mind, it certainly becomes critically important to be able to read and interpret the weather forecast so VMC can be maintained at all stages of flight, and also to plan our fuel burn correctly and our fuel on board. Don't forget your personal minimums also. Ask yourself, are you comfortable? Are you competent to fly with this particular forecast? A question for David from the ATSB. So Dave, as an experienced aviation incident accident investigator, how much of a role does weather contribute to reported accidents and incidents?
Yeah, thanks very much, Rob. So at the ATSB, we have received about 600 reports of occurrences involving weather, where weather has contributed in the last 30 years, and involving general aviation. And so there's been many more related to high cap airline flying, but for today, I'll focus on the general aviation sector, which includes notably aerial work and private flying. Sadly, each year we attend a number of fatal accidents involving weather, and we don't see that trend at the moment decreasing. And so we'd like to share what we know about that in the hope to try and reduce this rate. And really the solution is us all working together to do that. So you can see in the map shown, this is where the aviation weather-related occurrences typically occur, and that's consistent with our. It's generally consistent with where pilots are flying. However, there does seem to be an elevated area in places you might expect in the mountainous regions in the eastern side of Australia, and also some top end areas which are mostly related to winds and thunderstorms. So the types of weather occurrences that we see are shown here, and the big players are probably no surprises to those out there. Visual flight rules into instrument meteorological conditions, or VFR into IMC, make up the biggest proportion of weather-related occurrences that we have. And sadly, a lot of these are fatal. Behind that is something that we consider as other factors, other weather-related occurrences, and these typically involve it's weather occurrences that didn't really have a box, and so things like deteriorating weather. And Peter, thanks for that. So the colours represent the orange represents fatal accidents. Oh, sorry, just accidents. My apologies. The blue represents serious incidents, so things that came close to accidents, and the light blue represents incidents. And so, and typically we see, we would expect that there are a lot more reportable occurrences that have happened that just haven't made it their way through to us. So the numbers we expect are considerably higher than what's presented here. So yeah, so apart from also included in that other box are things like pilots getting caught VFR on top and being unable to find a hole to make it down. They're relatively common as well. And some of these have actually led into VFR and to IMC occurrences. On top of that, there's also wind shear, wind gusts and things like that occur typically during takeoff and landing. And importantly, also controlled flight into terrain, which, as you can see, there's a very large proportion of accidents that occur there, and they're not necessarily all related to weather. So some actually relate to light conditions as well. So I'll just run through a couple of case studies now, just to sort of set the scene as to the typical things that we're seeing happen. Starting with wind. So takeoff and landing related accidents are relatively common, and in this case, you can see in the image that's a Victor Air Tour. So basically, this was a landing accident where the aircraft simply got caught in a gust of wind, and it was a training flight where the student then unfortunately retracted the flaps too soon during the go around. And so it was a combination of factors like we often see. And so that resulted in a hard landing and then the aircraft overturning. But thankfully, both survived. So it's quite common for runway undershoot accidents. So landing short due to receiving gusts of winds and things like that is quite common. So really the big one, just quickly, apologies for the typo, that should read AMSL, above mean sea level for the cloud. But essentially this was just a recap. So I'll thank Rob for his input into that. And these are the minimums versus the alternate of 8,000 meters. And just keep that in mind for the next case study. So these are our most deadly weather-related accidents. Typically we see 3 fatal accidents every 2 years, and we've seen that over the last 30 years, and that trend is continuing. And importantly, usually there's at least 1 passenger on board with these. And so that's a ratio of more than 2 people per have died following VFR to IMC accidents typically. And it generally involves pilots who are untrained, who fly into cloud. And the research is very clear, and there's plenty of research out there where pilots are very likely to lose control within a relatively short period of time. And I'm sure many of you are aware of the fantastic work done by CASA, 178 Seconds to Live. If you haven't seen it, I recommend watching that. And associated literature around this, which is essentially spatial disorientation that occurs after flying into cloud. Typically, these aren't survivable. It's not survivable once control is lost. So from our investigations and also literature, one of the key things that comes up routinely is relates to assessing and planning related errors made, and so typically there's either an assessment of there's an insufficient assessment of the weather conditions. Pilots are unaware of the conditions that they're going to face, or the estimation of the aircraft and their own personal minimums is too high, which leads to the accident happening. Notably, it involves a number of very experienced pilots. So no one's really immune from these accidents. But it is less likely to involve pilots with an instrument rating. It's also important to note that with what's not included in these is VFR into dark night conditions. And so where if you're going to get caught out around the time of twilight, we've found that there's a number of accidents, at least 10 since 2011, where that's been identified as a factor. And so this is quite a problem in general aviation, in particular private flying. So I'll run through as an accident investigator what we would do to I guess come to these conclusions, and typically the evidence that we would collect following an accident, just for some background information. And so obviously we'd firstly get things like forecasts, TAFs, and the GAFs, observations. We also access pilot records and NAIPS login details from Air Services Australia. We'll also get air traffic control transcripts and find out information that was passed to the pilot, and look at third-party applications such as which might be on an iPad or a phone, such as an electronic flight bag. And typically what we're trying to do is work out what information was passed to the pilot before, or information that the pilot retrieved when planning, both before flight and also that may have aided decision making in flight. And what we're really trying to do is to really understand how the pilot came to the conclusions that they did um, to continue the flight often, that led to this happening. And although the literature is very clear, we're continually trying to improve our techniques to try and understand more, so that we can hopefully try and reduce the accident rate in the future. Another key factor that we use is the Bureau of Meteorology, who often conduct detailed analysis for us to estimate the types of weather that the pilots may have been facing. So this investigation, I'm just going to run through quickly now as a case study, which involved the use of electronic flight bag information, flight flight planning info from NAPES, so aerodrome forecast TAFs. At the time, it was area forecasts, and also GPS tracking data, and we used all that to put together this to work out what's happened in the flight on top of CCTV. So essentially, this was a flight which was designated as a community service flight on the 28th of June 2017. The pilot departed alone from Murray Bridge for Mount Gambier to pick up two passengers. And so at the time, you can see the TAF that was available to them to use, and so you can see the conditions are below the alternate and on the margin of the VFR limits. So it's fine to go so long as you've got an alternate for the arrival after 10 a.m. So you can see here that he did arrive within the period of the inter, and the flight path that you can see is the route that the pilot had to take during the arrival to negotiate clouds, and he had a couple of turns to try and go around. Had to go around on approach to the runway, and eventually made it in. And I think this is one of those cases where the conditions when he arrived were clearly below the minimums for visual flight. In fact, they were below the minimums for instrument flight as well. But the pilot managed to make it in, and I think this is, for me, a sobering reminder to remember that depending on your state of mind and what your plan is, you may actually, there's clear evidence that shows that people have pushed on to perhaps achieve a goal, or to finish the flight as they planned. Sadly, the flight didn't end there. So the pilot, after picking up the passengers, then taxied out in conditions that were below the minimums, and you can see the CCTV footage shown here, and that's the specie that was active at the time of takeoff, with a cloud base overcast at 200 feet, with visibility about 3,400 meters, as you can see. And the image on the right is showing that the conditions in the direction and the time of takeoff, and the image on the left is showing the aircraft arriving in the top right, the conditions on arrival. And I find this sobering to remember that although it may seem obvious to us at the time, there was a definite drive to keep going, to continue with the flight. It was a community service flight, so we think that the pilot was perhaps mission focused, and that may have contributed to his decision to keep going, to get the passengers to their medical appointment. So the Bureau of Met Analysis basically said that there were areas of patchy fog existing until mid-morning. The fog was lifting, but it persisted till late morning. So yeah, I think this is a sobering reminder to us all. Sadly, about 70 seconds after takeoff, the aircraft, the pilot with 2 passengers on board, entered the cloud and shortly after lost control, and it was not a survivable accident. So other factors that are rarer but do happen is unforecast weather, and that occurred with this investigation, which is the Norfolk, which is a ditching that occurred off the coast of Norfolk Island. And essentially the pilot, although there were other factors involved, the TAF that the pilot that was available at the time of flight planning predicted that the conditions would be suitable for the instrument landing. However, so that's saying that the conditions were actually predicted above the alternate minima, but had fallen below the landing minima. And so after trying 4 times to conducting 4 go-arounds after approaching the airfield, the pilot elected to ditch in the Pacific. And so one of the key things out of this, and I guess a takeaway to perhaps consider for your flying, is the important factor that forecasts actually degrade over time. And so the most current information that you can get is measurable in terms of the chances that you're going to get a forecast that's predicting what you need it to predict. And it really depends on how you use it, but the chart shown here is showing for a number of different airports, where on the left would be at the time of planning, and the 0 line, the origin, is reversed on the right, and that's showing the time of arrival. And the graphs, the data points actually show as the time gets nearer, the likelihood that you're going to arrive with conditions that you can't land when you've planned for an above alternate arrival. And so all this is saying is that receiving a forecast in flight, for example, will be generally beneficial, in particular for places like Lord Howe Island that you can see here. Appreciate that not all this is that all the aerodromes aren't shown, but certainly here there's a measurable effect on the likelihood of your success. So the message really is to plan to change plans. So based on the conditions that arise, be flexible with your decision making. We know from previous accidents that assessing and planning is critical with these accidents, and you can see that in the ATSB's avoidable accident series for VFR and IMC flight. And yeah, consider that the weather may deteriorate below forecast conditions. Even it may deteriorate below the landing minima, or the VFR minimums, even if it's predicted to be above. It's rare, but something to keep in mind. Thank you.
Dave, thanks very much for that. Certainly, it's good to hear from an investigator's perspective, and also having a look at those case studies as well. As you say, yeah, it's good to have a plan B and a plan C sometimes as well, because the weather does change. And certainly covered off in part one of the series that you can contact air traffic control and get those weather updates in flight as well. So it is really incumbent on us as pilots of any aircraft to ensure that we do follow the VMC weather requirements whilst we're flying under that VFR. To do this, we need to be able to correctly read and interpret the forecasts, obviously, that are produced from the Bureau of Meteorology. To that end, I'd now like to call upon Michael from the Bureau of Meteorology to run us through reading and interpreting the forecasts. Over to you, Michael.
Thanks, Rob, and great to hear from David as well. And thanks for inviting once again me along to this webinar to talk about our forecasts and the weather you can expect from that. So look, my job today is to go through how to interpret the aviation forecast that we put out. I'll be looking at graphical area forecasts, the GAFs, some grid point winds and temperature forecasts, some TAFs, and we'll finish up with looking at some synoptic MSLP charts and how you might use that to help your sort of general overview of a situation. As Rob mentioned earlier, it is listed in AIP, like what all the different acronyms or the different meanings of scattered and isolated and cloud amounts are, but I'll be alluding to that through the presentation as well when we get to it. I'll also, I guess, mostly be coming from a point of view for people who don't access these products on a day-to-day basis. Personally, I look at these all the time, so obviously they're very, very familiar to me. There's also probably some pilots in the webinar today that also do access these pretty regularly and have a fairly good insight into how they work. My presentation will be pitched a little bit lower than that, I'm sorry, but hopefully you'll bear with me and still get some good information out of this webinar. So we're going to start with looking at some GAFs. And I'll be doing this by looking at two GAFs today that you have that Rob put in the chat earlier and also put out with the invitation. Both of these GAFs were taken from a shift that I did last week. It was a night shift going into. It was in the early morning going into the into the day shift. One was a Queensland South GAF. Another one was a New South Wales East GAF. So we're going to start by looking at just a general overview of what the GAF looks like and what you can see on there and how we might interpret it. So looking at this GAF here on the top left-hand corner, you can see the graphical component of the forecast, a map of the area with various PCA points and various airports listed on there. You can see that there are, I'll say there are two areas that we're looking at here. There's an area B and there's an area A. So two areas that we're looking at. Within A, there's also a little bit of a subdivision where we're looking at there's some special other types of weather we'd like to allude to within area A. So the graphical on the top left. On the right-hand side, we come to all the text part of the forecast. At the very top of the forecast, you can see when this forecast is valid. So for this one here, it was actually issued, and it's a little bit hard to read. It was issued on the in 2022 on the 10th month, and on the 27th of October UTC time at 16:30 Zulu in the morning. But this forecast is actually valid from 23 Zulu the next day through to 05 Zulu. So in Queensland time from 9 a.m. through to 3 p.m. Down the right-hand side, you can see the table of information. It's split into 3 columns. The first column you see there is the surface wind and visibility. It's a list of the possible weather that you may encounter while you're flying within that particular area. And you can also notice as you go down that table, and we'll look at that a little bit more as we go on, that the weather is sorted into the greatest visibility down to the least visibility. The second column across talks about if you're in that particular type of weather, what's the cloud, what's the icing, what's the turbulence likely to be if you're in that weather. And then the far right-hand column is the freezing level that you can expect within that weather. On the left-hand side, again, going below the graphical component, and we'll look at these a little bit more later on as well. There's a text box talking about some implications or some implied weather, and then there's a big box for down the bottom for any remarks. That's plain language remarks that we may put in that forecast. So let's get into it. Let's have a look at Area B for a start. So Area B is quite a large area. So if you're flying anywhere within Area B, so it's most of southern Queensland, west of around about Emerald to Kingaroy to Sunshine Coast. So you might be planning a trip to Toowoomba to Dalby, you might be planning a trip Baduri to Quilpie. I'm flying in Area B. What's the weather that I can expect? So looking at the text part of the table, you can see that the weather there is nil weather. And if you are in an area where there's nil weather, you can expect that the visibility is greater than 10 kilometers. So looking across to the right, if you're in that area, what are the clouds that you can expect? So within that area, we've got few cumulus cloud. So few, just a reminder, means we're looking at 1 to 2 octaves or 1 to 2 eighths of the sky is covered, and we're looking at cumulus cloud. And the bases on that are, looking at that is, trying to read it because it's quite small on my screen, sorry, is 6,000 feet. So looking at bases at 6,000 feet, and the tops of those are above 10,000 feet. This forecast only goes to 10,000, so we're expecting that they're taller than 10,000 feet. But there's a bit of proviso in there as well. Those clouds you'll only expect if you are south of Thargomindah to St George to Goondiwindi. So it's really just at the southern part of that. So basically everywhere else within B, it's Cab OK. Looking further down that table, we're also expecting, because it is Queensland in late September, we've got moderate turbulence below 10,000 feet in PO, which are dust devils, and thermals. And look, the majority of it will be thermals. And anybody who's flown, particularly North Queensland, a little bit of South Queensland, Northern Territory, Northern Western Australia this time of year, you know you're going to get turbulence from thermals. So that's pretty much a stock standard phrase on most of our gaffs through the spring and summer months. So basically, the question you ask yourself, if you're flying in that area, can you do so safely? Can you maintain VMC? And the quick answer, of course, is yes. Let's move on to Area A. So the Area A is the entire area, including subdivision A1. So the weather you can expect in all that area from around about east of, say, Emerald to Taroom to Kingaroy to Sunshine Coast, anywhere in there. This is the area. If you're flying in that area, this is where you need to be looking. So within this, looking at the right-hand side of the table, if you're flying in this area, at the very top there, you can expect that you may come across nil weather. If you're in that area, there'll be some places in Area A where you'll experience nil weather. And if you're in an area with nil weather, then the visibility is going to be greater than 10,000 feet. Let's have a look at the cloud that you might experience if you happen to be flying there and you're in no weather. There's some scattered stratus with bases at 1,000 feet to 2,000 feet. And so that doesn't sound so good. But then there's a little proviso in there as well. It's only at sea, and it's only until 00 Zulu. So it's only if you're tracking, say, from the top of Fraser Island or Sandy Cape offshore somewhere that you might experience that cloud. Otherwise, within A, if you happen to be in no weather, then you've got some scattered cumulus or stratocumulus cloud. That's the 3 to 4 octaves worth of cloud, and bases are 7,000 feet to above 10,000 feet. If you're flying in Area A, looking down the next one, we may encounter some isolated showers. Now, isolated means anywhere from 0% through to 50% of the area could be covered with showers. And if you find yourself in a shower, then the potential is you may experience visibilities as low as 2,000 meters. So isolated within the entire area of Area A, but we give you a little bit more information. If you're flying in that subdivision A1, it's not just going to be just isolated, it's actually going to be scattered in that area. So 50 to 75% of the area we're expecting to be covered with showers. That's in A1, but that's only going to occur from 03 Zulu. And then on the right-hand side, again, looking at the cloud that you might experience if you do find yourself in a shower, we're expecting some pretty beefy showers that day. So we've got isolated TCU, towering cumulus, dangerous clouds to be near. We've also made another proviso there that it's, if you're actually flying in A1, it's actually going to be occasional, not just some isolated TCU. And there's some stratus associated and some broken cumulus and stratocumulus. Moving further down the table, within the entire Area A, you may encounter isolated thunderstorms through that area with an extra bit of information about A1. In fact, A1, we're expecting a lot more thunderstorms, occasional thunderstorms from 04 Zulu and the clouds associated with that. And worse again, moving further down the table, if you're flying in that area, within Area A1, we're actually expecting some thunderstorms with large hail, TSGR, GR meaning large hail, and we're expecting those hail storms to occur just in A1 from 04 Zulu. So again, the question you need to ask yourself is, can I fly safely within Area A, okay, and maintain BMC throughout? And that's, you'd have to obviously, as Rob alluded to earlier, you'd have to ask yourself lots of questions regarding that. With the weather forecast, you know, it sounds like if you're going later in the day in A1, it's not looking like a very good place to be. We've got occasional thunderstorms, we've got isolated thunderstorms with hail, with quite limited visibility. So that's something just to be very aware of course. So that's the description of Area A, remembering that this is the entire Area A, but we're giving you some extra information about a little area in there, A1. On the left-hand side of that graph, there's some information there that appears on every graph. And this is just to keep you reminding that all the heights that we give you on a graph are above mean sea level. They're not above ground level. It's AMSL. If you are flying within thunderstorms, cumulonimbus or towering cumulus, then it's implied that you're going to encounter severe icing and severe turbulence. If you're flying within cumulus or stratocumulus or altocumulus cloud, it is implied that you are going to experience some moderate turbulence. And finally, on the right there, if any cloud above freezing level, in this case, the freezing level is above 10,000 feet. But if you're in cloud above the freezing level, then it also implies that you've got some moderate ice occurring. So that's that happens on every graph. Okay, let's have a go at a more difficult or a more complicated weather gap, and this was New South Wales East for that day. So once again, we're looking at a forecast that's valid from 23 Zulu to 05 Zulu. Again, always working in UTC, so that we're all working from the same time zone. And you can see we have 4 areas of weather that we're looking at there. There's Area A, which is the northern half of the GAF area, including Area A1 or sub-area A1, so Area A there. I've got Area B, which having been around when this was done, this is basically the spine of the Great Dividing Range and west, and south of about Bathurst and Orange. It's Area B. Area C is on the spine and to the east of the Great Dividing Range, south of about Sydney. And then we have another area, Area D, right down the far southeast of that GAF. So again, looking at where you might be flying within that area, is it safe to fly? What are the weather experiences in a broad sense that you can expect? Let's start with the easy one. Let's start with A. So if you're flying in the north of the state, so all the area A, including Area A1, you can expect to come across nil weather, areas of nil weather with greater than 10 kilometers visibility. And if you are in those areas, the cloud that you can see on the right-hand side there, you can expect around scattered cumulus or stratocumulus cloud, bases of 6,000 feet up to 9,000 feet. Okay, that's generally the cloud that we're expecting. And if you remember what the Queensland South Gap had at exactly the same time, they just had a few clouds in Queensland, but in New South Wales, we've got some scattered cloud. And you might go, well, that sounds a little bit inconsistent. But from our perspective, there's also a line of ranges that runs right along the Gap border from about Coolangatta through to Gundawindi. And that's actually quite a good barrier for cloud. And we often see cloud build up in this particular regime on the southern side and less on the on the northern side. So look, A sounds like it's going to be okay, but there's a bit of a proviso if you're flying in A1. And by the way, that does include, I think, Bankstown. If you're flying in and out of Bankstown for that day, there was some moderate turbulence. Okay, we're expecting some moderate turbulence over land in A1. Moving down to area B. Now having a quick scan down B and you go, look, there's a lot of weather in B. I've got scattered rain, 4,000 meters. I've got isolated showers, 2,000 meters in B. I've got isolated snow showers, 2,000 meters in that area as well. So this is our main weather area. And if you're flying in this area, doing say a Wagga to Bathurst trip or a Young to Cooma trip or something like that, this is when you're starting to get a little bit concerned about whether you may be able to maintain VMC. If you're in area B, reading through the table again, you may encounter areas where there is no weather. No weather. So nil weather, greater than 10 kilometers. There are some areas where we won't have any weather, but look at the cloud that's associated with it. We've got scattered cumulus and stratocumulus with bases 5,000 feet up to tops of 8,000 feet. But we give you some more information. If you're in B1 or B2 down the south, those bases are actually at 3,000 feet and broken. You're really going to struggle to maintain VMC with all the topography around there in B1 and B2. We're also expecting some scattered ACAS, 7,000 feet and above. Immediately that starts to say to you, look, if I'm trying to fly in the south there, I'm going to really struggle in that one. And that's, I guess, the story that we're trying to get out with this GAF. Because you look at the next one, we've got 4,000 meters scattered. So 50 to 75% of the area is going to have rain that may have visibilities as low as 4,000 meters, but this is just in area B1 and B2 again. And looking at the cloud associated with the rain, it's not real flash. Broken stratus, 1,500 foot to 3,000 feet. Stratocumulus from 1,000 to 7,000 feet, and ACAS above that. So really, we're trying to say to you, if you want to fly in B1 and B2, you really need to be instrument rated. Also, we've got some isolated showers and some snow showers down in B1 and B2 as well. So again, you have to interpret that. Go, can I fly safely within area B? Also, looking on the right-hand side there, looking at the freezing levels. The freezing levels are 7,500 feet in the north, lowering to 5,500 feet in the south. So again, if you think, am I going to encounter icing conditions? And we actually take a number of calls, not from necessarily VFR pilots, but from instrument-rated pilots, checking those freezing levels, because it is quite broad, because they're looking at, okay, can I maintain my minimum safe and stay out of icing? So B is looking like a fairly poor weather area. Area C is the spine of the ranges into the east, and it's not looking, you look at it and it's not too bad. We've only got weather with nil and greater than 10 kilometers visibility. We've got some scattered cumulus with bases at 5,000 feet, and there's just a little bit of ACAS above that. But the reason we have identified this one is because we've got some severe turbulence in there. Looking underneath that, we've got severe turbulence below 7,000 feet, and we've got moderate mountain waves above. The reason this was today, we had some really strong westerly winds, and that was actually driving all the weather onto the western slopes, and it's maintaining fine weather on the east generally, but lots of turbulence. And then finally, without labouring the point too much, going down into area D, which is sort of around Merimbula and down to the Victorian border, we have highlighting there, the third box down with D, is that we've got some thunderstorms in that area. So we wanted to delineate, I guess, where the thunderstorms are. So with the GAF, we're trying to pass on a story to you. Okay, where is it safe to fly? Where are you going to be able to maintain visual or not? And the story you're looking at this GAF is the northern half of the state. Doesn't look too bad. be aware of a little bit of turbulence north of Sydney. It looks like southern western slopes of New South Wales are a no-go area today. Be very aware if you're flying in the east, because there's lots of turbulence around and possible thunderstorms in the south. I'm sorry, this is my poor slide work there. I've just cut off the left-hand side there. This is in the remarks box, particularly with New South Wales East and with the Victorian gaps. There are critical locations. There are 3 critical locations in New South Wales East, being Murrurundi, Bowral, and Mount Victoria. And Kilmore Gap is the one for Victoria. And so we give you a TAF-like forecast for those critical locations. And again, apologies that I have managed to snip off the left-hand side of those forecasts, but just so you know that the top one is a Murrurundi forecast, where we're forecasting just scattered cumulus at 6,500 feet. And we also do list with those critical locations what is the height of the topography. In this case, elevation 2,300 feet. We're forecasting scattered cumulus at 6,500 feet. So you've actually got around about 4,200 foot separation between cloud and ground there. I have mentioned in the red box there, you can, if you want a full explanation of gaps, in fact, any of our forecasts, you can go to the Knowledge Centre at the Bureau of Meteorology website. If you look underneath Aviation Services, and there's a, I know this is being recorded, so you can see that website or that web address later on, and you can get a full detailed explanation of gaps. So let's move on to the grid point winds and temperatures. And when you first look at a grid point wind and temperature forecast, it's easy to get overwhelmed, because this is the state of New South Wales and a little bit of Victoria and a little bit of southern Queensland, and there's just numbers everywhere. Okay, but it's when you actually get into it, it actually gives you good detailed information about the winds and temperatures at any one particular site. And we're going to start off by, I'm going to just have a look at probably the area around Mildura to Swan Hill is probably fairly easy to see. I'm not sure if you can see my mouse, but looking at the southern parts of or southwest parts of New South Wales. And we've got lots of numbers sitting in there. What I have done is I've blown up the information area down the bottom left, and I've just put it at the top right. Basically, what it's telling you is when you look in that grid point square, it's giving you the information for the middle of that grid point square, but most of this information should be valid for if you're flying within that square. The bottom row of numbers refers to information at 1,000 feet. The second row of numbers up from the bottom is 2,000 feet. Then 5,000 feet, then 7,000 feet, 10,000 feet, and finally at flight level 140, right at the top of the range. And it gives information in wind direction and wind speed. So the first number you see there, if you're flying, let's say you're flying around the Mildura Swan Hill area at 2,000 feet. The numbers you can see in that there, the first number you come across is 26. So that means the wind is coming from the direction 260. So it's almost like a due westerly. The next set of 3 numbers refers to how the wind speed, in this case it's 024 knots or 24 knots. And then the last number there is plus 10. So the temperature at that level is 10 degrees Celsius. Just be aware that this is again for the middle part of that box that we're talking about there. So that's how to read it. What we've also got some people who have said, well, how do I actually know which square I'm in? So also you can obtain, again from the Bureau of Meteorology website, an overlay of the exact same size with some point locations on there. And if you overlay one on top of the other, and I guess maybe some people do this by paper or by their computer. You can then, if you're planning a flight from, again, maybe I'll pick Echuca to Broken Hill, then you can actually line up, well, where is Echuca, where's Broken Hill, and I can see which squares that I'm flying through. So that's how to read that. There's just a couple of other things I'll just note. If I move out towards Canberra, and you can see Canberra, as an overlay there. There's a number of squares along eastern New South Wales and around the ACT that are missing information in there. In fact, there's from 1,000 feet and 2,000 feet there's missing information. And of course, that means, of course, that within that square, you're over the Great Dividing Range. So 1,000 feet and 2,000 feet are actually below ground level because you're within the ranges there. So if you are missing information, that's because you're over the topography. Once again, down the bottom of that slide, I've got direction to our knowledge centre within the Bureau of Meteorology website that you can go and get more information about grid point winds and temperatures. And quickly, because I know I'm running a little bit short of time here, let's move on to onto TAFs and how you read those. I'll just review very quickly what I mentioned the last webinar. TAFs are it's terminal area forecast. It's forecast of the expected conditions within 5 nautical miles of an airport. Just a reminder, like all of our forecasts, they're in Zulu time or UTC time. Cloud amounts are, as we've seen in the GAFs, few 1 to 2 octas, scattered 3 to 4 octas, broken is 5 to 6 octas, and overcast is 7 to 8 octas. While the TAFs give you a forecast of the expected conditions, one of its main reasons that it's there is it dictates fuel requirements. Are you below minima? Do you have to carry extra fuel as a result of the forecast? And once again, down the bottom, I've also pointed once again to the knowledge services website that we have on within our website that gives you more information. So the TAF I've got there, we'll have a quick look through it, is for forest, which is halfway across the Nullarbor. Fairly important TAF if you're trying to cross the Nullarbor, heading either east to west or west to east, sort of right in the middle of nowhere, and I believe it's probably a fuel supply. But if you needed to drop into forest for whatever reason, let's have a look and see if we can interpret this TAF. The very top line says TAF for forest, gives you an issue time, but the important thing at the very top, this TAF is valid from 0102, so that's on the 1st of the month from 02 Zulu, and it's valid until 0114, so the 1st of the month, it's the 1st of November actually, at 14 Zulu. If you are going there, the conditions that you can expect are winds from 200 degrees, so a south-southwesterly, 15 knots gusting to 25 knots. You can expect unrestricted visibility in light showers, minus SHRA. And the cloud that you've got there is scattered at 018 or 1,800 feet and broken cloud at 035, 3,500 feet. So the question, is that below minima or above minima? In this case, that's above the minima that Rob mentioned before, 8,000 meters visibility, cloud at 1,500 feet or broken. So you don't actually have to carry any fuel, extra fuel to get in there, but just be aware of what the conditions are. We then have a from line. So expect a change from at on the 1st of the month at 03 Zulu. At 03 Zulu, we're expecting the winds just to not change that much, actually, just another knot in it, but 9999, unrestricted visibility, nil significant weather, the showers are going away, and with it, the cloud rises to 4,000 feet. So looking good probably from 03, except it's still quite gusty. And then from 09 Zulu, the winds change yet again and ease, they're no longer gusty. 170, almost southerly winds at 14 knots and very few clouds. Down the very bottom of every TAF, you've got temperatures in every 3 hours. 16 degrees at 02, 18 degrees at 05, 17 degrees at 08, etc. And also the expected QNH. As mentioned in the last webinar, if those values are out, they're wrong by a couple of hectopascals, then we amend the TAF. Let's move quickly on to a more difficult or a more complex TAF, which was Bankstown on this particular day. And this is it was amended TAF. We had to change the TAF. I can't remember why, but we did. Bankstown, and it's valid from the 1st of the month, 1st of November, from 00 Zulu, and it's valid until 12 Zulu that evening. The winds are gusty, 280 westerlies, 20 gusting 35, but not much in the line of clouds around, only few at 045. And if you remember the gap that we had before, remember that was within area A, and so we weren't expecting too much weather in that area. From 05 Zulu, from 01, the first month at 05, we're expecting those winds to remain quite strong, but change direction by 30 degrees, 310. They're now west-northwesterlies. We're expecting some showers to move in, and with the showers, just a little bit of cloud, and then those showers go away from 11 Zulu. More importantly, the fourth line down is an inter. So inter means periods up to 30 minutes between 05 Zulu and 10 Zulu. We can expect some very gusty winds and 7,000 meter visibility in showers with scattered at 2,000 foot cloud. So you got to say, do I have to carry fuel for that? And if you're VFR, the answer is yes, because we're expecting visibility is less than 8,000 meters. And so then you have to carry an extra 30 minutes of fuel to cover that, that inter. And as you might remember in the GAF, there's also a remark down there that from 00 Zulu on the 1st, we're expecting some moderate turbulence below 5,000 feet. And that's consistent with the GAF. Unfortunately, we're also expecting some severe turbulence late in the day, or in fact in the evening, and that was beyond the GAF period. So that's a bit of a more complex TAF to look at. And again, knowing I'm running a little bit out of time, I'll move on to interpreting mean sea level charts, or mean sea level pressure charts. Now you can find these charts, I guess, on the Bureau of Meteorology website. I've got a URL there that you can have a look at, and you can go through the main page and find this information on the website. It gives you information at the surface. It doesn't give you information that might be happening at 5 or 6 or 7,000 feet, but it does give you a bit of an idea of what you might, weather that you might expect. This is the looking at this one here. I actually think I took a more interesting MSLP chart. This one was due. No, my apologies. It was on the same day. So this is the MSLP that was due on the 1st of November at 11 o'clock that day. So things to look at when you're looking at an MSLP chart. Wind flows in an anti-clockwise direction out of a high. So it doesn't actually directly follow the isobars around. They flow anti-clockwise and away from a high. Now, in this case here, we had a high that was lying just to the southwest of Perth. And so the winds that you would expect around the Perth or the west coast of Western Australia would be roughly southerly, I would think, from here, because the winds are trying to go in an anti-clockwise direction around that high, but they're also trying to flow out of that high. And so roughly end up at being around about southerly. Now, the opposite happens within a low. Winds flow in a clockwise direction, is in the southern hemisphere, and they flow into a low. So they don't just follow the isobars around, but they're trying to flow into the low as well. In this case, we have a low well south of Tasmania. And so winds are trying to flow not just from the north around there, but also flow into that low. Generally, high pressure means that we have rising air. Sorry, my apologies, opposite way. High pressure means we've generally got descending air through the atmosphere, and that generally means stable weather, generally, I'll say. And then the opposite around a low. A low pressure system usually means rising air and unstable weather. Other things to look at here are ridges. They're extended areas of high pressure. I'm not sure if you can see my mouse at all, I suspect not, but coming out of that high to the southwest of Perth and pushing across Western Australia into southern Northern Territory, you can see there that the isobars do sort of push further away, and there you've got a ridge of high pressure. The opposite occurs with troughs. Troughs are localised areas of low pressure. So there's a trough that's moving through Victoria and Western New South Wales, and we do mark that on the map. That's where we got, you can see the isobars actually wrap in a more sharper clockwise direction around that trough, and that's an area where we get more instability and often more inclement weather as well. Other things to look at on this MSLP chart are the how close the isobars are together. Generally, the closer they are, the stronger the wind strength. It does matter how far north or south you are over the continent, but generally the further they are apart, the lower the wind speed. The closer they are together, the faster the wind speed. And then we've also got marked on this map here some fronts. In this case, we've got mostly cold fronts in blue, And frontal weather is where we have one air mass displacing another. In the case of a cold front, we have cold air in behind the cold front displacing with some warm air ahead of it. And as soon as you have warm air being forced to rise or displaced by cold air, then you get rising air and then you get weather associated with it. So in this case, we have two fronts, one way south of the continent and the other one which was providing weather that had moved through eastern New South Wales and is still lingering around eastern Queensland. So just to what I did at the same time was I overlaid the satellite on that MSLP chart, and you can see what we're just talking about there. So the cloud features with that front over Eastern Australia line up nicely. We've got cloud just ahead of that cold front with the warm air rising ahead of it. We've also got some cloud in around the trough through Victoria and New South Wales, so plenty of weather there. And the big ridge that's over northwestern Australia and the big area of high pressure has got not much cloud there at all, so pretty stable weather. And with that, Rob, I probably should stop there because I know I've probably gone on long enough. But if you do want to, at any stage, want to give the Bureau of Meteorology some feedback, then you can see we've got a QR code on there. You can use that to hand any feedback back. Thank you.
Michael, thanks very much for that. And folks, yeah, thank you very much for staying with us on the webinar. We've gone a little bit over time, but of course it's all valuable information that we've had. So again, a big thank you to Michael and also for David for the valuable assistance in constructing this webinar today. And I really do trust that everyone has found it a good session in interpreting the forecasts and visibility of how weather contributes to aviation incidents and accidents. It's also a quick reminder of our alternate minimums and our VMC criteria as well. So don't forget these minimums, and the VMC criteria are found in the Visual Flight Rules Guide, the VFRG, on the CASA website, in the Civil Aviation Safety Regulations and accompanying manual of standards. And on that note, I'll just put it out there. I know we're a little bit over time, but does anyone have any questions at all? I see there was a couple of things that are put in the chat, and Michael, thanks very much for answering those. As I did say in the beginning as well, this webinar is recorded and it will be found on the Pilot Safety Hub of the CASA website. It will be available for viewing probably by the end of the week, I would say. Barry has his hand up. Ask away, Barry.
I was just wondering, is there a reason that the general Met forecasts are only available on the NAPS website, but not on the NAPS app? NAPES, I should say, NAPES website, but not on the NAPES app.
Very good question. That I actually haven't found that on the NAPES app. I know on the website itself it gives it all, but I haven't had too much experience on that.
And look, I apologise as well, Rob and Barry as well. Like I also don't have any experience with the NAPES app. That's something I guess Air Services would have to respond to.
Thanks anyway.
Thank you. Yeah, usually just I'm old school. Unfortunately, I just usually print it off the NAPES website. Yeah, Chris.
G'day guys, great presentation, very helpful indeed. Quick question, when using Oz runways, and it's probably similar with AVPlan, when you are asked to calculate the or download the winds for your flight plan, it gives you two options, a grid point forecast, low level, or NAPES. Why would they give you two, and which should I be choosing?
A very good question, that one. Definitely use the NAPES as well, but the grid point wind and temperature should come out of NAPES as well.
Well, you'd think, but when you pick either one, you'll get different information. So I've always found it strange that it would give you two options with different data.
Yeah, definitely. It's something we probably have to chase up with Oz Runways as well, because the weather should certainly the only legal requirement for to get the weather is
Sure.
off the NAPES website. So yeah, I'd certainly be using the NAPES.
Will do. Thanks, guys.
No worries. Okay, I see another couple of hands up there. Barry. Barry Fitzgerald.
Unmuted. Sorry, I realise this is a bit academic, in fact, quite academic, but in the presentation on GAFs, it was mentioned that ISOL means 0 to 50% of the area covered. What does occasional represent? And also, purely for reference, would those definitions be in the BOM Aviation Services Knowledge Centre?
Yeah, great question. And you are exactly right. So isolated also refers to isolated thunderstorms. However, when it comes to thunderstorms and CB, where we have scattered in terms of cloud, that is respectively occasional. So occasional refers to 50 to 75% of the area.
Oh, great, thank you.
Yep. And sorry, I just the second part of your question, just remind me again. Sorry.
Oh, it was just that ISOL meant 0 to 50% of the area covered. Yep. And so I got scattered as 50 to 75%, but I didn't know whether occasional, whether that had a percentage definition as well.
Yeah. Okay. Thanks. I hope I answered that one okay.
Yep. Thank you.
Thanks.
Thanks, Barry. Eric.
Yeah, so my question's in relation to the GAFs and the different areas and the boundaries, and I'm just wondering what range those boundaries take. I mean, obviously there's not a arbitrary line where one weather system stops and another one starts. So is there a range for that boundary?
Great question. And from our perspective, there's not a range. So that's where we're saying the area stops and finishes. We do take great care in making sure that we include certain aerodromes within a particular weather area. For example, the one in Queensland, we made sure we needed to include the Sunshine Coast within the thunderstorm area that day because there was a chance of getting thunderstorms there. So we do take care about where we want the boundaries to be, and hence there's no buffer area, so to speak. If we get a significant weather phenomena outside of our hard area, then we do issue air mets. So, for example, on that day we had thunderstorms in Queensland South, around the northeast of the area. I was on a night shift, so thankfully I was sleeping through that time. I don't know whether the storms ended up forming in the right area or not. But like say they did actually form outside where we assessed they would happen, then for us it's an immediate air met to alert that we've actually got some of this significant weather outside of where we were forecasting.
Thank you.
Thanks, Eric. Bearing in mind the time, folks, unfortunately we will have to wrap it up. The recording, as I said, will be available shortly on the CASA Pilot Safety Hub. And stay tuned, though, for our next series of webinars, which will be on pre-flight planning. So keep an eye out for when they are advertised, and I hope you can all join us again for those. So I'll take this opportunity to say thank you again and goodbye. Have a good afternoon.